back to the channel. In this video series, we'll explore one of the most important topics in chemistry, chemical reactions and equations. This is part 1, where we'll understand what are chemical reactions, how do we know a reaction has occurred, the key terms, reactants and products, introduction to chemical equations, and the important concept of balancing equations. Let's begin. Chemical reactions are happening around us all the time. Burning of fuel, rusting of iron, cooking of food, digestion in our body, all are examples of chemical reactions. So, what exactly is a chemical reaction? A chemical reaction is a process where atoms of substances rearrange to form new substances with entirely new properties. For example, when wood burns, it changes into ash, carbon dioxide, and water vapor, all very different from wood. That's why we call it a chemical change. How do we know a reaction has occurred? There are certain signs that tell us a chemical reaction has taken place, change in state. For example, water changing into gas during electrolysis, change in color, rusting of iron turns it brown, gas evolution, bubbles when baking soda reacts with vinegar, temperature change, it may become hot, exothermic, or cold, endothermic, formation of a precipitate, an insoluble solid settling down in a liquid. These clues confirm that a new substance has been formed. Before we go further, let's remember two important terms. Reactants, the substances that take part in the reaction, i.e., the starting materials. Products, the substances formed as a result of the reaction. For example, in the reaction, hydrogen and oxygen reacts to form water. Hydrogen and oxygen are reactants. Water is the product. A chemical equation is like the shorthand or language of chemistry. It represents reactions in a symbolic way. Example, magnesium reacts with oxygen to form magnesium oxide. Magnesium plus oxygen form a new product, magnesium oxide here. The arrow shows the direction of the reaction from reactants to products. Now comes a very important step, balancing equations. Why balance? Because of the law of conservation of mass. It states that mass can neither be created nor destroyed. That means the number of atoms of each element must be equal on both sides of the equation. Steps to balance, hit and trial method. Write the unbalanced equation. Count the number of atoms of each element on both sides. Start with elements that appear least or have maximum atoms. General order, metals, nonmetals, oxygen, hydrogen. Adjust coefficients, numbers before formulas to balance. Recheck to confirm. Unbalanced, Mg plus O2 converted to MgO balanced. 2 Mg plus O2 converted to 2 MgO. Now both sides have equal atoms of Mg and O. To make chemical equations more useful, we add two things. Physical states, S denotes solid, L denotes liquid, G denotes gas, AQ denotes aqueous solution. Reaction conditions, heat, pressure, or catalysts. CO, gas, plus 2, H2, gas arrow under 340, atmospheric pressure, CH3 OH liquid. Here the state of each substance and reaction condition are clearly shown. So friends, in this first part, we covered what chemical reactions are, signs of a reaction, reactants and products, how equations are written, and how to balance them. In part 2, we'll study the different types of reactions, combination, decomposition, displacement, double displacement, and redox reactions. We'll also see how oxidation affects our daily life through corrosion and rancidity. Don't forget to like, share, and subscribe, and click the bell icon so you don't miss part 2. See you in the next class.